Welcome to my presentation today about the Industrial Cloud Federation and details about how to leverage data-driven services in industrial environments by open unified standards. First of all, let me give you a short introduction of the company I'm working for. Hikuma is a special purpose machine and plant building company for the plastics industry with more than 45 years of experience. We are a classical SME with about 160 employees located near the Munich airport in Germany, and we have our own manufacturing and production facility to build up the plants and machines we are selling. We are delivering approximately about 30 systems per year. And what is the challenge here? Basically, we are engineering the whole machine from scratch. We are developing pneumatic systems, mechanical engineering, electrical wirings, and the automation software for sure. In the end, we have a huge supplier and partner network delivering components, supporting us with technology. So we are playing the role of a system integrator as well as of the machine builder itself, and tackle with a lot of complexity in building up, constructing, mechanical construction, and for sure operating the machines and delivering it to our customers. At the moment, we are faced with a disruptive evolution in industry. For sure, you are aware of the different steps of the industry evolution from Industry 1.0 to Industry 4.0. But what is now in Industry 4.0 the novel thing? Based on the current technology, Industry 3.0, which is automation, computers and electronics, as already mentioned before, now in Industry 4.0, we are dealing with the IoT, with the Industrial Internet of Things, which is enabled by the Internet, by pervasive communication technology and networks, and for sure upcoming more and more artificial intelligence software components, which are placed on-premise in the machines, but also somewhere in virtualized computing environments in the clouds. And therefore, we are changing the overall system structure more and more. In research, as well as upcoming in technical papers, you can more and more see the discussion of the evolution of the structure of the networks from the classical automation pyramid, which is an hierarchical organization of computing entities, from high-level enterprise computing down to actuators and sensors on the field level, towards a networked communication of all these functionalities and structures, where the actuators and sensors are physically located still on the field level. Nevertheless, it is a distribution of the computing capabilities, of the processing capabilities and all of the data across the machine, but also to IT infrastructure of the manufacturer, to cloud services which are provided by customers or by the suppliers, by the machine vendors, to improve machine performance, to predict behavior, to identify abnormal situations, and provide additional functionalities to improve machine operation and machine maintenance. As a result, the networked communication mentioned already before results in the following situation depicted on this slide. On the left-hand side, you can see the machine which is placed on the manufacturer side. Typically, the manufacturer is consuming some data to the MES system, to the SCADA system, in order to track the products, to observe the performance of the machines and so on. Nevertheless, upcoming due to novel processing and computing services which are provided by, for example, the machine supplier like Hikuma, or component suppliers which are the suppliers to the machine builder, for example, companies for pneumatic systems, for sensor systems, PLC control and all this stuff. They have additional, or for example, also robotics. They have additional services which provide, for example, prediction about maintenance or performance analytics or all this stuff. As a consequence, the machine builder acts as an, let's say, system integrator and may provide also to the machine, to the operator, to the manufacturer, additional services, or the manufacturer is additionally buying these services from component vendors or the machine supplier. In order to facilitate services which are running on cloud systems, and typically they are operated on cloud systems specifically provided by component suppliers. They have their own infrastructure, they have their own operation environment for clouds. So there are special platforms where the services are running, and the services have to be provided with data. As a consequence, the machine builder is forced, for example, to install a lot of different edge devices, because these cloud component suppliers, the clouds of the component supplier are in the end not the same. They are based on different platforms, based on different architectures, and it is very the typical way is that they are provided specific edge computing devices for handling the communication. So the machine supplier is forced to install a couple of edge devices in order to facilitate the communication and integrate the services of some component suppliers or even sub-suppliers of the component suppliers. And in the end, the manufacturer is forced to monitor a lot of different communication channels and also maintain all these communication channels and all these devices. This is very cost extensive, very complex, and it is also not very good to be monitored which data is passed to which company and why. So this is a very challenging situation at the moment. Exactly this is the starting point for the so-called Industrial Cloud Federation. Assuming that various services are deployed on different cloud platforms of the machine supplier, of the component supplier, which is the supplier for the machine building company, also of sub-suppliers is shown on the right-hand side, which are suppliers providing components to a component supplier. All these services are required to be integrated. For example, artificial intelligence services, maintenance services, or prediction services, performance monitoring services. And if the manufacturer wants to use them, it is his decision to integrate these services, also in combination or collaboration with the machine supplier, especially with the special vendor supplier, to ask them to integrate this during the engineering of the machine and provide required facilities for the communication. So in this application scenario of the Industrial Cloud Federation, the whole communication is through the cloud of the manufacturer. This means that the classical interface, which is already provided by machines in order to provide data to the manufacturer, can be used to route data further based on legal contracts, for example, to a supplier, and he is also able to integrate or route it to sub-suppliers, so to his suppliers like component suppliers or the sub-suppliers. And for sure this communication is very flexible. If the machine supplier is not integrated, there might be also a communication from the cloud of the manufacturer to a cloud of the component supplier. Nevertheless, as you can see, there is only one connection point to the machine which has to be maintained, and at least only one communication protocol which is used to communicate data to the manufacturer's IT system, and then the data is routed through different clouds. So as a consequence, if we are providing the situation or moving forward to the situation, we will have a multi-cloud environment for each machine. And if the manufacturer has, for example, machines of different vendors, you have the situation more and more and at much more clouds and services to be integrated. So this is one situation which is obvious for an industrial cloud federation, where you can track the data very easily by the manufacturer. You can configure which data is passed to which component supplier and integrated services, and you can monitor it. And the important thing here is that you use at least one unified standard or a set of unified standards in order to enable such multi-cloud environments. Another situation is more or less equal to the starting point of the network communication, but for sure there might be a need or a reason to not communicate everything through the cloud of the manufacturer. For example, if it is a virtualized environment, in this case, data which comes in and is routed out of the cloud may result in huge costs, or there is no cloud of the manufacturer at this time. So there is also a reason to, let's say, route data directly from the machine to some machine supplier services or component supplier services in different clouds. As a consequence, there should be no need for the manufacturer to support or enable a cloud or provide a cloud, but it should be able to configure the communication and not to maintain a huge set of different edge computing devices and different communication links, but to have one unique edge device which can be configured in a standard way by the cloud manufacturer, also some kind of monitored by the cloud, by the manufacturer itself, and then configure it which service of a supplier, for example, machine supplier, component supplier, should be integrated. So as you can see, all the communication channels reside in a single point connected to the machine. So in order to facilitate and realize an industrial cloud federation, in the end, multiple stakeholders are involved. For example, the service provider. This might be a component supplier, or for example an AI tech company which has a novel technology or novel algorithms to, for example, predict some behavior. These service providers have to know how to connect, how to gather the data from a machine, and for example the system integrator, the machine building company, has also to know how to integrate these services in order to provide his customer, the manufacturer, a machine which is improved, for example, by additional services or AI algorithms. So in the end, there is a need to know very directly how to implement and integrate service providers. And if you have no common standard in this context, it is very complex either for the service providers as well as for the system integrator to handle various communication channels and protocols to integrate such services. Additionally, for field level asset providers like the machine builder, like the component suppliers, they have to know which technical requirements must be fulfilled in order to participate in such an industrial cloud federation, which protocols should be supported, how data is described in a uniform way, and all this stuff. Thirdly, the manufacturer, the plant operators, need also to know how to configure the enterprise IT, which requirements and protocols should be supported, how they can implement and manage such industrial cloud federations. And last but not least, it's also important that the cloud providers are on board, because there are requirements how to enter how to connect to clouds regarding, for example, the security, the data transmission and all this stuff, and also how to route data to other cloud and platforms. So it is very important that all these different stakeholders are on board when implementing an industrial cloud federation. In order to facilitate the implementation, standardization is a good way to provide a common best practice, to define a set of technology, protocols and all this stuff where everyone agrees on, and then the implementation and setup of Industrial Cloud Federation is much more easy. And exactly this is the reason why we decided to develop an open, unified environment based on standards for the Industrial Cloud Federation. Already some years ago, the Platform Industry 4.0, which is the community with industrial companies, academia, politics and research to drive the Industry 4.0 in Germany forward and also connect on an international level, we identified that it is necessary to support some Industrial Cloud Federation technology and these efforts. Therefore, there was initiated a field of action and a so-called breakthrough undertaking in order to understand and identify how Industrial Cloud Federation works, which are the requirements, and also how to standardize them. Afterwards, a standardization project was initiated. I will give some insights later on, and then also some test beds for SMEs and also big companies, which is hosted by the so-called Labs Network. Industry 4.0 was initiated to practically evaluate and standardize in an agile way. So I will give some details on these aspects in the next slide. First of all, let's have a look on the details of the so-called DIN-Spec, the standardization project for standardizing Industrial Cloud Federation. The DIN-Spec 92222 defines a reference model for Industrial Cloud Federation and was funded by DIN in order to develop collaboratively a standard and the requirements. As you can see, we had more than 40 participants of 33 partners investigating these aspects, and thereby all the different stakeholder groups were participating and bringing in their requirements and technological ideas. Also, research were supported, for example, by Fraunhofer. We had some machine building companies like Hikuma. We have the component suppliers, for example, like Harting and Hitachi. We had service providers like Expleo. We had cloud providers, for example, like IBM and Microsoft, robotics and drive systems, controllers, and also the conformance validation. So all the companies and their experts brought their ideas and brought their experiences in order to realize and define a reference model for Industrial Cloud Federation. But what is a DIN-Spec? The idea of a DIN-Spec is an agile standardization. As already mentioned before, also supported by the test bed, we developed within the DIN-Spec project how to ensure the interoperability and facilitate communication on a practical level. So we implemented some test cases, we implemented some showcases to identify what is possible and what not, and in the end identified how a reference model for Industrial Cloud Federation should look like. One of the most important things in this project were already that OPC UA as a starting point was already defined, because the OPC UA is the basic standard for industrial environments, and therefore we had already a look on OPC UA and identified how to implement an Industrial Cloud Federation based on the reference model based on OPC UA in a first step. So we had a look if it is possible and how to realize it with the established standard OPC UA. The standard, the DIN spec 92222, is published recently. So the basic question is how to proceed next, how to directly establish such an open unified standards environment for realizing Industrial Cloud Federation. So how to drive the efforts of the Industrial Cloud Federation forward? The OPC Foundation, I think I do not need to describe too many things about this OPC Foundation itself. But for the Industrial Cloud Federation, the OPC Foundation means that this is a huge collaboration platform integrating information models and data of different aspects, for example, from the IT level, from the engineering, from the factory automation level, and also provides a huge communication stack which is well defined and already widespread across industry. So the OPC Foundation provides a good starting point for realizing and further developing the Industrial Cloud Federation for, as the name already says, the industrial environment. But the basic question is, do we need some further support and let's say additional know-how and expertise which cannot brought in by industrial partners? And here an additional company comes in, the DIN, which is it is not a company, it's an institution which comes into play. And now I want to hand over to my esteemed colleague Katharina Senert for presenting some details about DIN.
Thank you, Christoph. My name is Katharina Senert. I'm the project manager of the DIN Spec Industrial Cloud Federation at DIN. Founded in 1917, DIN, the German Institute of Standardization, is the independent and neutral platform for standardization in Germany and worldwide. DIN is a private organization. As a partner for industry, research and society as a whole, DIN plays a major role in helping innovations to reach the market in areas such as the digital economy or society, often within the framework of research projects. More than 36,000 experts from industry, research, consumer protection, and the public sector bring their expertise to work on standardization projects managed by DIN. The result of these efforts are market-oriented standards and specifications that promote global trade and encourage rationalization, quality assurance, and the protection of society and the environment, as well as improving security and communication. At present, there are 34,000 documents in the German Standards Collection. These are published by DIN's subsidiary Beuth Verlag. 69 committees work on topics ranging from acoustics to water management. From Industrial Cloud Federation to pacifiers, stairs to nails, ladders to toothbrushes, almost everything in our daily lives is covered by standards. Roughly 85% of all national standards projects are European or international in origin. And there's a good reason for that. International standards are the common denominator and shared language of suppliers and customers. They facilitate the transfer of technologies and trade and ensure technical compatibility. They support regulation in health, safety, security, and environmental matters by being at the cutting edge of science and technology. They also ensure that trade agreements are successfully implemented and are a source of technical expertise. International standards ensure the access to global markets and to strategic information on market development and technological innovations. They give access to strategic partnerships and to important ways of cutting costs, improving performance, extending regional and international markets, meeting certification and conformity assessment requirements. And DIN opens the door to this world, since DIN represents German interest in international organizations such as CEN, the European Standards Body, and ISO, the International Standards Organization. In corporations, DIN ensures that current national, European, and international standardization activities are considered and can be built upon. Thank you, and now I hand over to Christoph.
Thank you, Katharina, for this short introduction. So, as you can see, DIN is very established in the standardization environment. They are, as in Germany, established as well connected on an international level. So it is obvious that the OPC Foundation and DIN are good partners and a perfect starting point for open unified standards for realizing the Industry Cloud Federation based on OPC UA. Therefore, we are starting the joint working group OPC UA for Industry Cloud Federation in order to minimize the number of standards required to realize Industrial Cloud Federation, as already mentioned, and thereby rely on already established standards like OPC UA, but also some other communication protocols which should be integrated instead of developing some new things. Because there are so many stakeholders involved in realizing an Industrial Cloud Federation, all initiatives, consortia, standardization bodies, organizations, technical committee members, and members of other institutions and organizations, interested companies are invited to join and contribute to the joint working group on OPC UA for Industry Cloud Federation in order to develop an open, unified environment of standards to realize such an Industry Cloud Federation and collaboratively enable and achieve interoperability across clouds, across companies, and especially providing the data flow and integration of services for industrial environments. So let me summarize with a slide you have already seen. Based on the ideas which were originally initiated by the Platform Industry 4.0 and then standardized within the DIN Spec 92222, we have further now started a joint working group of OPC UA for Industrial Cloud Federation in a collaboration between DIN and the OPC Foundation, which is very important for the machine building companies like Hikuma, but also for the cloud companies like Microsoft and all the other companies and all the stakeholders which were mentioned before. Therefore, let us follow the idea of Industry 4.0. Let us collaborate and find together an open, unified environment, or let's collaboratively define an open, unified environment of standards for Industrial Cloud Federation. Please be aware that the kickoff will be in July 2021 and the call for actions for this joint working group will distribute it soon. So thanks a lot for your attention. In case you have any questions, do not hesitate to contact myself, Christoph Legat, or my colleague Katharina Senat. We will support you and we are looking forward to your collaboration within the novel joint working group on Industrial Cloud Federation between DIN and OPC Foundation. Thanks a lot for your attention.